Hello again, CS211 folk. If you've already watched the scanner video, now's the time to tune into this video, which is about the Lab 02 classes that are given to you, that you have to work with. This will pay some dividends, and that the chords class, which we'll look at first, actually shows up in the Project 3 spec as well as something that you'll have to use. One caveat to that, it's called coords with an S in the lab and coord in the project. We did that just to confuse you and make life miserable, but they are in fact the same class. Let's have a look first at chord. You see it on the screen before you. The chords class keeps track of a two-dimensional coordinate, usually for a grid, a row and column coordinate. Java doesn't give us a default way to keep track of pairs of things or triples or anything like that. That would be way too easy on us as programmers. So instead we have to roll our own little class, and I've done that here. Chords is interesting in that it has two public fields, row and column, and they're final. Final is a keyword that indicates once specified, those variables will never change. So in the only constructor for the coordinates class here, when you build a coordinate, you say I want this initial row and this initial column. The coordinate that's being built will take those values for its row and col, and afterwards you can never change the integer row or col for the coordinates. This should be somewhat familiar in that once specified, the lengths of arrays can never change, but the final keyword is something you can use in your own classes from time to time when you want to make sure that there is a constant, something that does not change. Note that the default value for these is 0, but you're allowed to write to them once, which is done in the constructor. There are a couple other methods for coordinates of interest. The toString method, which presents a string version that looks semi-nice of the coordinate, prints it as a tuple of integer. And there's also an equals method. As you should have covered at this point, by default, objects comparing to one another need some sort of sensible way to specify them. Equal equals does a shallow comparison, which is what the default equals method does for all objects. We certainly don't want to compare coordinates based on whether they're the exact same object, but rather by whether or not they have the same row and column attributes, fields associated with them, which will return true. So in order to make a coordinate, I can ask for chords C, for instance, say new chords, and maybe I'll ask for the coordinate 1, 2. So here's C. As we've said before, Dr. Java gives the string representation for the coordinates. The system.out.println should do the same thing, trying to convert it to a string. So this makes it fairly easy to follow along with what's going on with the coordinate, because we can actually see it, see what it is. Here's another one, coordinate C2. Maybe we'll make that also 1, 2 for the moment. You can ask things like, is C dot equals C2? And in fact they are. You can also look at what the row and column value for each of these guys is. However, trying to set something like C dot row equal to 4 instead will result in an error. Dr. Java recognizes this in the interactive loop as an error, and the compiler, Java-C, will recognize this as an error at compile time because you've specified that row and col are supposed to be constants. They shouldn't change after the first write. So that's coordinates. They're used along with the TreasureMap class, which compiles out of the box in order to keep track of a simple 2D grid of treasures. Now there are two kinds of locations on a 2D grid, kinds of locations that are not of interest and kinds of locations that have treasure in them. In order to make treasure maps, you're going to have to specify two constructors, but there is a constructor that is out of the box functional. It's a little bit troublesome, which is why we're going to force you to implement a couple other constructors for it. Basically, treasure map keeps track of how big it is in terms of rows and columns, and also how many treasure locations it has in an array of coordinates. So in order to make a treasure map using the default constructor, I need to specify these things: how many rows and columns, and where are the treasures. It's easier to do that if I already have an array of coordinates sitting around, so let's make one quick. Recall that making arrays of objects is not very different than making an array of primitives. Just need to say coordinates array CA equals a new coordinates array, And I'll use the immediate specification to say I want these coordinates in it. New coordinates at 1, 2, new coordinates at 3, 0, and a new chords maybe 3, 3. Bear in mind that we'll have to make sure that our treasure map is big enough. Dr. Java is smart enough to actually print out what the array looks like, 1, 2, 3, 0, and 3, 3. However, in your own programs, if you rely on a system.out.println, there is no good toString for arrays in Java. If you want to do that, I suggest you look up the java.util.arrays class, which has a static toString method which can convert an array of objects to their toString representation, which prints reasonably nice. I use this one a lot when I have primitive arrays, particularly in your test frameworks. At any rate, now that we have an array of coordinates, we can make a treasure map. Let's do so. Here's a treasure map. Maybe I'll call him TM and say new treasure map. Let's make sure he's plenty big in terms of rows and columns, maybe 5 by 8. And the third argument is that array of coordinates we just created. If you look down, there is a nice toString method for treasure maps that goes to a significant amount of work in order to construct a nice string representation of that. What it amounts to is we can actually see the treasure map, and it looks pretty nice. Let's verify for a moment. I had coordinates for treasure at the following locations. 1, 2. So if I go row 0, row 1, and then column 0, column 1, column 2, there is an X there, that's good. How about 3, 0? The 0, 1, 2, 3, 0, that's good. And 3, 3, 0, 1, 2, 3, 0, 1, 2, 3. Looks like this treasure map was successfully created. Treasure map doesn't allow you to access its stuff, its internals directly, but it does have a nice accessor, a treasure at, which returns a Boolean true or false based on whether or not there is treasure at a particular location. You can probably tell all this does is loop through the array of coordinates and ask the R and C values, are they equal to the coordinate row or coordinate column of the treasure locations. And if it finds one that matches, it will return true, and otherwise if none match, will return false. We can say tm.treasure at 0, 0, which should return false. tm.treasure at how about 1, 0, 1, 2, where we did put one, and yes indeed there is. How about at 3, 0, where there's another one, but not at 3, 1, and we're good. So that's treasure map. Now what you're to do is to improve upon the state of affairs right now, in which treasure maps only have a single constructor that require a fair amount of information. What we want to do is do two things: make it easier to build treasure maps. First way to do that is to specify a constructor, which will be the default no argument constructor, that prompts the user of the treasure map for direct input about its stuff. You're to ask how big is the treasure map, how many treasures there are, and then repeatedly ask for treasure coordinates and store those in the treasure map that's being built. You can demonstrate this with the working key version of this. Here's a treasure map TM equals new treasure map. No arguments, and this is a constructor that you are to build. So this will use Java's ability to get input from the user, probably using the scanner class, to prompt for the various inputs that are required. For instance, I need 2 integers to specify the number of rows and columns, so I'll maybe say this is 2 by 9, kind of a skinny treasure map. Enter the number of treasures. Well, let's say there are 4 treasures. We'll put them at 0, 0, 0, 1, and maybe 7, 0, and let's see, how about 6, 1. So the particular prompts that you print we're not very interested in, but if someone specifies this size and this number of treasures, you should repeatedly ask for coordinates to represent that, and if then I asked what does my treasure map look like, I get an array out of bounds exception. That's fantastic. The reason for this out of bounds exception is because I have reversed in my head the notion of the size of the treasure map, I said 2 by 9, which means 2 rows by 9 columns, but have then gone on to give very big row locations, like 7, 0, and 6, 1. For your work on the lab, you are not required to fix problems like this. In fact, users can give terrible positions for treasure maps. During testing, we won't ever give you terrible positions like this. The position 6-1 is well outside of the boundaries of the map. Let's fix that by giving ourselves a different treasure map. We'll say same bounds, the number of treasures 4, but this time I'll limit myself to inbounds treasure locations. So now when I look at my treasure map, I should see, my 4 treasures at 0, 0, at 1, 0, at 0, 7, way over here, and at 0, 4. So all is well. The final thing to do with the treasure maps is to write a second constructor. So I guess that'll be the third constructor overall, the one that's given to you in order to build treasure maps. The default constructor, which takes input from the user. The third one you're to write is a treasure map that reads from a file. And the particular format of the file is exactly like the string output that treasure maps are supposed to look like. There are a couple examples given. Here's one, map1.txt. It's much easier to give or to build a treasure map if we can simply say there's one in this file, please read it and set it up for me. So a demo of that, over here, your method should go in here and take an argument that is a file name that contains a treasure map. Demo of that over here, maybe I'll make a treasure map tm2, which equals a new treasure map, and I'll read from map1.txt. Let's see if I take a look at tm2, it looks like such. Empty first row, 2 treasures in the second row, nothing in the third. And if I look around in this directory, and note Dr. Java, we need to tell it to look at all files instead of just .java files. Here's my map1.txt, and lo and behold, it looks very much like the treasure map that I built from it. So a couple things to keep in mind. The treasure map is not a 2D sort of object. It has a 1D array of coordinates, of locations, and a notion of size. You're not to do any error checking on treasure locations versus size, so if things blow up, that won't be your fault. However, when you're reading from the file, and you'll have to do repeated sort of reads of lines, and then probably use methods of the string method to figure out each of these characters, whether or not they're a period or an X. You probably need to go through the file once in order to count how many treasures there are, and then allocate an array, go through the file again by resetting back to the beginning of the position, and then fill in the coordinates of treasures as you find them. Hope this helps you guys get started. You'll have a 1-day extension until Wednesday next week in order to finish this lab. Have fun and enjoy the rest of your snow days.